Good morning, everyone, and welcome to our Thursday webinar this week on LiDAR-based road design. In today's session, we're going to cover some easy techniques for using LiDAR data in RoadEng. As usual, we will be recording this session. So if we happen to go over, you need to leave, or if you want to share it with a friend, we will send out the link afterwards and you can watch it again. And secondly, you are muted. So that means that you can't ask a question out loud. However, we encourage you to engage with us throughout our presentation using the question section in your GoToWebinar panel. With me today is Jack Rymack. He's one of our applications engineers, and he is going to be covering road design with LiDAR data. There's a few key steps he's going to be taking us through. First is importing LiDAR, then some thinning techniques, which are very important for ensuring the software is going as fast as it can for you, creating a 3D model, pegging his horizontal alignment, and then doing some quick vertical alignment and a little bit of earthwork balancing. Before we get started, though, I did just want to introduce 3 quick concepts that can help you make the most of your LiDAR data. As many of you know, LiDAR data can be in very, very large sets, and the larger the set, usually the slower it causes the software to go. So in order to make sure you make the most of your LiDAR data, there's 3 sort of rules or principles that we like to use here. The first is to avoid gridded data. The key point is basically around the fact that you're not getting any new information. You're just adding a ton of incremental points. So don't use pre-processed data, avoid gridded data, and just use your raw LiDAR file. The second point, and Jack will be covering this in detail, is the idea around selectively thinning your data around your corridor or area of interest. This allows us to have full resolution where we need it and lower resolution outside of that area. As Jack will show you, you can go back afterwards and bring in other areas in full resolution. The final point and idea with LiDAR data is around grouped data. Now, this point really only applies to ASCII data sets. When importing these, it's important to leverage the combined features options that are available during import. And this, again, is all about not taking up as much memory. Today, Jack's going to be using an LAS file. And with this, it automatically imports as grouped features. So, enough from me, and over to you, Jack. Oh, sorry, one thing. Upcoming webinars. This is just 4 of our other upcoming webinars. If you're interested in attending them, we've got Introduction to Software Optimal coming up 2 weeks and a day from now. Some looking deeper at generating output sheets, Friday, July the 8th. Importing and exporting coordinate data in RoadEng on July the 22nd. And then finally, terrain tools. One of our other programs gets to center stage, and this is really just a deeper look at the terrain module for those of you who have RoadEng. And this is all about understanding our 3D modeling functions. All of these webinars, plus a couple more, are available for registration on our softtree.com website. And with that, this time I will actually pass it over to Jack, and he can start us on the proper webinar.
Thanks, Erin. Thank you again for that introduction. Hello, folks. My name is Jack Rymack. I'll be doing the presentation of the import of LiDAR data sets. I'm just going to run through the steps that I will follow. First of all, I will import some shape files that are road shape files. They have a whole bunch of roads with three roads in them, and I will then import the LiDAR data, use those roads to thin out the LiDAR data to for corridor of interest, and then tin and model the surface. Then I will actually go and do a road design of this. A horizontal alignment, vertical alignment, and that's going to be the end of the demonstration. Let's start. First of all, I'm going to open up a bunch of shape files that will represent my roads. And the shape files are projected to a coordinate system that's out east, eastern Canada. Next step is to import the LiDAR data set and use my roads as a thinning corridor feature. File, insert file. Hold the shift key down to select both. I got two tiles here, two LAS files. Go back to the LAS import options tab. Make sure that I have ground selected, which I do. If you have all points selected, make sure you turn those off and make sure you have the ground, because you don't want any of this other low vegetation, medium vegetation, or high vegetation, or any of these other buildings to appear. All you want is your ground, because that's what you're going to base your design on. And if you have display points turned on, turn that off. And if you have display extent border turned on, turn that off. Just because it takes a little bit more memory to display the points, which you don't want to have to deal with every time. So just turn those off. We've already dealt with the projection. Let's just go quickly to the projection tab just to show that it is projecting from an undefined projection to a known world projection out east. Go to the selection tab. So this is the tab where you actually bring in all of your corridors and give it a corridor width and change your resolution. Add a corridor. I'm going to select this corridor first. I'm going to have a corridor of 100 meters, so it's going to be 100 meter width. Corridor width that I will be not thinning any of the data. So basically, within that corridor, I will be thinning 0 data. Add the next one. Corridor 2. Finally, corridor 3. Okay, like I said, none of the data within the corridors will be thinned, but outside of the corridor, which is this, which is the default option here, we're going to thin out. You choose whatever you want. It depends on what your comfort level is and how much you want to thin out. I like to thin out every 9th point, so once it thins out 9, it will read the 10th. I could press OK right now, but I don't want to go through the, it will take a little while to actually import all the data, so I'm just going to show you the final result. Let's just go to the final result, close that down. So this is what the data looks like after you have thinned it. You can see that definitely we have thin data on the outside and full density data on the inside of that corridor around those roads. Next step is to notice that when I select in blank space, the points actually disappear. That's because in that option where I had show points in the import of the LiDAR data, I turned that off. And I only turned them on momentarily just to show you what the corridor width looks like. Let's do our tinning contouring right now. I'm going to select the end of this road because that's where I'm going to start my alignment when I go to the location design module. Press the generate tin. Calculate triangles. I can include all triangles because the data is basically a rectangular data set, so it doesn't really matter if it's it will all stay within that rectangle. All the tin will stay within the rectangle, so there's no real problem. Contours. I like a contour color of red for my minor contours and a contour color of black for my major contours. Press the plus sign beside each of these to change their color. My minor contours will be at 2-meter intervals. This file is in metric. For our friends down in the United States, you obviously would be dealing in feet. So the units that you see here would be different. They would be in metric, in imperial units feet. This is imperial of metric file, sorry. Minor contours, 2-meter intervals, major contours, 10-meter interval. You can see that the elevation starts quite low. This being a file from out east, it actually might start at close to sea level. And then go quite high in elevation. Let's just do our contouring. This will take a couple of seconds. So once it finishes contouring, I'll quickly show you a 3D view of it, and then we'll go on and design the road. Let's go into Window, New Window, Graphics, 3D. I'm going to save my file right here, and then I am going to delete the contours just so that you can see the 3D view without contours. Just make sure I save this. Get rid of the contours. Click this button right up here to delete the contours. There, looks better without contours, I think. Just the surface. It's quite a nice surface if I do say so. All right, I'm going to start my design from, I saved this file, so I really don't have to worry about, let me just open it just to make sure that I've saved it with the contours. Let's go on to the location design module. File, New, Thinned. If you notice, I do have a full resolution file here. What that file is, I'll just quickly show it to you after I've done my my design, starting of my design. I'm going to start at that current point that's selected on the at the end of that road. I'm just going to continue the road design on. Let me quickly go back to the terrain module and show you that full resolution file. Okay, so this is a file that hasn't been thinned at all. I'm going to show you later on how to switch the thinned data set with the full resolution data set in the location design module. Before I do that, let me just start our design. I'm going to get a screen layout that sets my screen up for horizontal alignment. Get a set of templates that are metric templates. Resource metric. I'm not going to fiddle around with the templates. Just going to leave the default. I'm going to show you how to connect. I'm going to run this road up here and just connect it to the end of this one. Right click. Get your added IP tool, which is your pencil tool, adds your alignment, your PIs or IPs. Left click twice to add in an IP or PI. Left click once. Left click again to tie it down. You can see that the software is automatically putting a grade on that line because I had the grade labels turned on. Finally attach, snap to that endpoint right there, attaching back to that existing road. I do want to do one more thing and just put a curve on here. So I'm going to snap again over here, put one curve on that at that endpoint. 100 meter curve should be good enough here. Apply. Set that as my default. Jump back. Get my default. Apply. Jump back. Get my default. If I had a large radius, let me just show you what would happen. Let me just put in a 200 meter radius. Yeah, see that message? Curve does not fit tangents. That means that there's another curve. If I try to fit a 200 meter radius curve, there's another curve or another IP in the way. In this case, this curve is in the way. Let me just make that, get my default and put it back to 100 because 100 works. You can move around your alignment after and make sure that it's the right location. The curve will maintain its 100 meter radius. Let's go on to vertical alignment. Before I go do that, let me show you how to, I mentioned before that I was going to show you how to switch your files from the thin resolution file to the full resolution file. Go into Module, Setup, Alignment, Terrains. Right now it's using the topo surface as the thin file. Browse for the full resolution, which is down here in my web demos area. Switch it for the full resolution file. Onto vertical alignment. Get my screen layout for vertical alignment. Now this screen has a profile, a section, and a data window. Let me just make sure the data window is populated with the correct information. I'm going to change it so we're seeing 100 meter intervals for volumes. We also have a vertical curve panel and the optimal panel, which for people that aren't aware, this is our it's a dual panel. It's our vertical optimization panel as well as a costing panel down here, so you can see what costs you have for your road. put it in alignment, and then we'll see how the costs change as I put it in alignment. Again, the pencil tool, this time you go from left to right. I'm going to try to balance out the road manually as much as possible. You can see right now we have balance at the beginning, but we start getting a lot of cut at the close to the end, or a lot of waste at the end, or middle and end. Let's try to balance that out a bit better. Left click anywhere to the right of that first IP or PI. Left click again to tie it down. Let me pull that up a bit more. Left click again. You can see that the, let me just change the cost information, auto cost and recost all. So as I move my alignment around, you'll see the cost change. Left click once. You can see that that went up to $20,000. Left click once. Left click again to tie it down, it went up again. Go up here, and then snap back down to the start of the profile, or the end of the alignment there. Go back to my vertical curve panel, add in some vertical curves, and then I'll go back and see how the cost changes as I move my alignment around. Jump back to my second IP, get my default. I'm going to change that to actually a 10K. That would give me a 53 meter or 54 meter long curve. Apply. Set that as my default. Jump. Get my default. Apply. Jump. Get my default. Apply. Jump. Get my default. If I get this message, then I have to just simply move this IP away from that one. Get my default, apply. Jump. Get my default, apply. Got a little bit of cut, excess cut at the end, but I can get rid of that by just pulling this alignment up. Let's go back to my optimal panel and just show you how the costs change as I change my alignment around. So if I cut more, theoretically you will be getting more, a greater cost, because in this case, let me just go to my costs and just show you. In this case, we are, the cost is much higher for excavation than it is for fill. You have to get your own costs correct and just keep them the same. Don't fiddle around with them too much. So you can see that was a drastic increase because I just cut a lot more. I can also go back to my plan window, change my horizontal to a different location, and the cost will change again. Let me just, I lost a curve here for some reason. Let me just go back to my vertical curve panel and get my curve back. The reason I lost the curve is because I was fiddling around with the horizontal, and that curve could no longer fit. Get default, apply. Pull that back up. I'm pretty well balanced at the beginning of the alignment. You can see that the colors you see here are showing me that the green is free haul, yellow is overhaul, red here is waste, but I can get rid of that waste by pulling up on our alignment, getting rid of it, and at some point, once I pull it up enough, you will start to balance. I got a little bit too much waste at the end of this alignment. Like I said before, let me just pull up and get rid of some of that waste. All right, just to recap what I did, I brought in some shape files into the terrain module, imported LiDAR data sets, 2 tiles, used the shape files to do a corridor thinning. Showed you a 3D view of this once I did a tin and contour of it. Came in to do a design, a simple plan and profile design of my alignment. Showed you the costs, how the costs change as you move your alignment around. This is a very short road, so the costs will be very small, in the thousands of dollars instead of the millions of dollars. And then I showed you how to switch a thinned resolution file in the location design module with a full resolution file. And to create a full resolution file, let me quickly show you how to do that. It's quite easy. I'm going to go back to the terrain module. Full resolution file will be quick. Let me just open up my shape files again. This time I'm not going to thin anything out. Same projection. File, insert file. Remember to select both of these LAS files. Open. No thinning this time. Then make sure that I have ground selected. So no thinning at all. This will be very fast. Let's see, it's very fast to create a full resolution file. It's a little bit longer to do a thinned file because software has to actually go through and find where the points are in relation to where the corridor is. So we've got the second file already started. You can see that it looks like it's thin, but it's not. It's actually the road surface. The existing road surface actually has more data than the surrounding area, because there's a lot of trees that the points have to actually penetrate. The road surface doesn't have any trees, so that's why the existing roads are look like they've been thin, but they haven't. There's just a full resolution. Points definitely hit the road a lot easily than if they have to go through trees and brush and other vegetation. That's why it looks like it's been thinned a bit, but it hasn't. Thank you very much. That's the end of my presentation today.